This is the last lesson in our unit on sequences and series. And today we're going to be talking about binomial expansions. So the goal, what we're going to do is expand a binomial product using the binomial theorem or Pascal's triangle. The why underlying this is that the binomial theorem provides an example of how many seemingly unrelated math concepts arise in different fields of math. We often think of math as being one nebulous field of really challenging things, but math is actually many smaller subfields like geometry, algebra, things like calculus and topology, number theory, geometric topology, algebraic geometry. There's many different subfields within math. And when we see how they come together and overlap, it really brings a greater depth of and richness to the subject. So on this next slide, we want to compare, contrast, and analyze. Normally in class, we take a few minutes, you talk with a classmate. We can't do that virtually. So instead, what I'd like you to do is pause the video for a couple minutes, look up and down. I don't know why there's a red dot there. Look up and down what you've got and what's here, and see what patterns you can see. When you're ready, hit play. And I will assume now that you've spent a few minutes, we're going to talk about some key observations. First, if we look at the exponent and call it n, there's one more term in each expansion. So x plus y to the 0 power is just 1. X plus y to the first power has 2 terms. Squared has 3 terms, and so on. Notice that x and y have symmetrical roles. So if we have x cubed, we have y cubed. If we have 3x squared, we have 3xy squared. And the same when we have x to the fourth, we have y to the fourth. 4x cubed y, 4xy cubed. And then this one, 6x squared y squared, well, it's both x and y squared, so that still upholds the symmetry. Next, the sum of the powers in each term equals n. So if we have the power of x is 1, the power of y is 1, that adds together is 2. It's a little bit more obvious if we have 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4. The coefficients increase and then decrease. So it goes 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And so we see that they increase and then decrease. And so what we want, our goal, is if we can determine the coefficients for each term, we can more easily expand a binomial without multiplying it term by term. If we're multiplying something squared, that's not very challenging. But if we double that and then double it again, it becomes incredibly time-consuming and tedious. So this is going to wrap up the first video. It's kind of the goal setting for this lesson. In the next video, we're going to look at the binomial theorem. And then in the following video, we will look at Pascal's triangle.